Assalamualaikum warahmatullahi wabarakatuh. As for the CFD project for Fluid Dynamics KKMM3223, our group 26 with the members of YUAN, Kang, FAREESYA and me, Muhammad AIMAN, chose as the title of our project to be Throttle Pedal Influence on Inlet Valve.
The problem statement for this investigation is: first, the airflow in automotive engine combustion systems affect performance, emission, and reliability. Design optimization involves fluid dynamics, heat transfer, and component interaction, considering factors like air-fuel mixture, chamber geometry, and valve timing. The study combines experimental techniques and computational fluid dynamics to investigate this element. So the objective of this study is we need to identify airflow patterns at various positions of throttle opening, which is at 25%, 50%, 75%, and 100%. So the second objective is we want to analyze the effect of air inlet temperature at 50 degrees Celsius, 20 degrees Celsius, 25 degrees Celsius, and 30 degrees Celsius on the temperature distribution in the intake part.
For our design modeling, it was quite simple. It was just a combination of a valve and a body of an engine cylinder head. As you can see here, this is the cross-section area of the assembly. If we take a look closer, you can see that there's a hole on the body which allowed the valve to move upward and downward. Then, to set the opening position, we need to declare a reference plan which can be reference point for the valve. The 1 mm distance refers to 25% opening, 2 mm, 3 mm, and 4 mm correspond to 50%, 75%, and 100% opening. Before we go through the meshing analysis, I have to create surface at the inlet and outlet in the design modeler. This allowed me to apply the function of fill, and it will fill the volume of the body. Then in the meshing panels, I will do meshing with element size of 0.0015 meters, which is the most optimized size. And before we proceed to the next stage, we have to create the name selection based on inlet, outlet, fluid flow, body, and valve. For the graphical output, in which we represented it in velocity vector, is in this form. At the left hand side is the legend which indicates the range of velocity magnitude. The blue color is the lowest range, while the red color is the highest range. For the animations, you can notice that the red color is concentrated at the valve and entry of air, which makes sense in terms of Bernoulli principle. When the area reduces, velocity increase. For the second research objective, we display the output in the variable of temperature difference. For the legend, is indicate the total temperature difference, while the blue color is the lowest temperature and red color is the highest temperature. For the animation, you can observe that even though the inlet temperature is lower than the body temperature, but in the end, it will reach equilibrium and the temperature will be the same.
First research objective is to identify airflow patterns at various positions of throttle openings, which are from 25%, 50%, 75%, and also 100%. As the throttle opening increased from 25 to 100%, there were significant changes in both pressure and velocity within the intake port. So this table shows all the results of the pressure and velocity for different throttle openings. Therefore, when throttle openings increase, pressure in intake port decrease, and also velocity in intake port increase. This table shows that the transition from negative to positive velocities as the throttle opening increase illustrates the shift from turbulent to laminar flow patterns. At lower throttle openings, the high pressure and negative velocities indicates turbulent flow with significant recirculation and resistance. As the throttle opens further, the reduction in pressure and increase in positive velocity indicates a smoother and laminar flows with efficient air movement through the intake port. These results are important to the throttle control in optimizing airflow dynamics by minimizing turbulence and maximizing laminar flow, which significantly enhancing engine performance. Our second research objective is to analyze the effect of air inlet temperature from 15, 20, 25, and 30 degrees Celsius on the temperature distribution in the intake port. So, from this table, when the inlet temperature increases, the heat transfer is increasing slightly, and also the temperature distribution is increasing. In summary, as the air inlet temperature increases, the efficiency of heat absorption by the air decreases due to the reduced temperature gradient between the air and the intake port surfaces. Each increment in air temperature leads to a less negative temperature distribution, indicating less effective cooling. These changes directly affect the thermal management within the intake port, highlighting the critical role of maintaining optimal air temperatures for efficient heat transfer and temperature distribution in enhancing engine performance. For conclusion, in this project, we are able to analyze the changes in airflow patterns and temperature distribution at different throttle positions, specifically from 25% to 100% of throttle openings. This variation allows us to identify different trends in airflow behaviors, from more stable and laminar flow at higher throttle openings to turbulence and laminate flows as throttle openings decreases. Other than that, the investigation into the impact of air inlet temperatures ranging from 15 degrees Celsius to 30 degrees Celsius on temperature distribution within the intake port reveals significant insights for optimizing engine performance. The varying inlet temperatures influence temperature distribution by affecting air density and mass flow rates, thereby affecting the thermal environment within the intake system. In conclusion, this project is considered successful because we had achieved its objective by providing a comprehensive analysis on how throttle positions and air inlet temperature affect airflow dynamics and also temperature distribution in the intake port. This result contribute to a deeper understanding of engine behavior and pave the way for better advancement in engine efficiency and performance optimization.